Assalamu alaikum. My name is Jamal Ahmed Khan from CS department. The question given to me in the quiz was Rolle's theorem. So basically, the statement of Rolle's theorem is that let f be a continuous on f function be a continuous on interval closed interval ab and differentiable on open interval ab, such that f of a is equal to f of a means the initial value is equal to final value, and at least there is one number c in the closed interval a, besides that the derivative of that point is equal to 0. Continuous means in a working formation, and a differentiable means changing. So here assume a function that f of x is equal to x square minus 3x plus 2. So the function is not changing, so f of x is equal to 0. So we get the values x is equal to 1 and x is equal to by solving the above function. And for checking these value in the function that it is 0 or not, we put the values in the function. In the first value, x is equal to 1, it gives 0, and x is equal to it also gives 0, you can say. So both functions are equal. So for point c, we have to take the derivative of the function to find the value of c. By taking derivative, it gives 2x minus 3. So function is not changing, so we put f of prime of x is equal to 0. So we get the value of x is equal to 3 by 2 or 1.5, which is between the initial and the final point. Let represent this function on a graph. Here you can see in the graph we have the value a and b, which are on the same position, and no change with respect to the y-axis. There is no change. So function 1 is equal to function 2. Here function 1 is equal to function 2, and ya is equal to y, means there is no change in the y-axis. So the c is equal to 1.5, which is in between a and b. So point c, the c is in between a and b, so it is the average of point a and b, which is the concept of Rolle's theorem. Means it is like rolling, so it is also named about this concept, which is Rolle's theorem. Thank you so much.
Presenting the Rolle's theorem. Rolle's theorem, basically what the Rolle's theorem is and how it's implemented in our daily life. Rolle's theorem is the special case of mean value theorem, which is the main concept in the differential calculus. Firstly, this what is its statements and who presented this. It was presented by the Mitchell Rolls, and after that, after his invention, this theorem was named as the Rolle's theorem. And what's the statement? Rolle's theorem states that if the function is continuous on the closed interval a b and differential on the open interval such that f of a is equals to f of b, then the f bar of x is equals to 0. Means that now how it's implemented, or how can we elaborate it seeing this example, seeing this graph. Here we started our journey. One started his or her journey from the point A to and move towards point B. His aim is to reach point B. So he started from point A and cover a distance passing through C and reach to the B. So this is the closed interval, and the Rolle's theorem states that in a closed interval there might come a point at which the derivative or the rate of change becomes 0. So thus this is we say that it's a Rolle theorem can be implemented as this, and the if we are considering as the absolute maxima and minima values, then according to absolute maxima and minima value, the Rolle's theorem states that at the end point, at the starting point and the end point, means that in the interval point A and at point B there will exist the absolute maxima and minima values, and there got three conditions here. Number one is that the derivative becomes zero in this closed interval. Secondly, the derivative does not exist in between these two absolute maxima and minima. And the third point is that the endpoints are the domains of the functions, or A and B are the we can say are the domains of the function f of x. So this graph shows that from point A to B, so somebody travels, and at the point 3 points, there come the 3 points for c1, c2 and c3. There the derivative of the functions becomes zero. So this can be explained by the daily life. We can also relate this in our daily life. It's actually calculus is all related to our daily life, practical life example. Let's suppose we take an example that we started our journey from some theorem can be implemented as this, and if we are considering as the absolute maxima and minima values, then according to absolute maxima and minima value, the Rolle's theorem states that at the end point, at the starting point and the end point, means that in the interval point A and at point B there will exist the absolute maxima and minima values, and there got three conditions here. Number one is that the derivative becomes zero in this closed interval. Secondly, the derivative does not exist in between these two absolute maxima and minima. And the third point is that the endpoints are the domains of the functions, or A and B are the we can say are the domains of the function f of x. So this graph shows that from point A to B, so somebody travels, and at the point 3 points, there come the 3 points for c1, c2 and c3. There the derivative of the functions becomes zero. So this can be explained by the daily life. We can also relate this in our daily life. It's actually calculus is all related to our daily life, practical life example. Let's suppose we take an example that we started our journey from some destination, and we have to reach some fixed point. So thus we let's suppose I start my journey from Hanpur to Peshawar. Then the point Hanpur and Peshawar are the boundary points, we can say boundary points, and the interval lies between this, and these the 2 points are also included because it's an closed interval. So let's seeing this here. We started from this point Hanpur, and we have to reach the point Peshawar. So we started our journey from Hanpur to Peshawar, and we followed different paths to reach Peshawar. We can go through the motorway, and also the and we have also have to follow the some local routes. So in this interval, the points, these points are the maximum, absolute maxima and minimum points, and the interval between them, there got some point, there came some points, and at that points the derivative, there is no rate of change, we can say there is no rate of change, or in the other words we can say that the rate of change equals to zero. So and this is a complete we can say code of the Rolle's theorem, and the Rolle's theorem explained can be explained by other examples like our daily routines, and it's all related to our life. Thanks.
Assalamu alaikum, sir. My name is Mohammed Iqbal, and my topic is Rolle's theorem. In Rolle's theorem, f of x is continuous over the closed interval of a and b point of its interior, then at least one number c should be zero. In Rolle's theorem, he tells that function of a and function of b are same, cause these both are continuous function, right? And in your previous lecture, I think number 19, you say you have giving example of humans breathing, and that humans breathing is a continuous function after his birth till death. Before death and after his birth, the process in his life, the change, the continuous effect, his breathing, are all included in Rolle's theorem. Now, sir, I want to give you an example. Sir, minus x square plus 6x minus 6. Sir, we have to factorize it. Factorizing. Sir, the video length is too long. Then I have I knew the possible outcomes. Then I written as right x minus 1, x minus 5, right? But when we come 0 and take it outside, other side of the 0, right? X equal to 1 and x equal to 5. So these are two outcomes, two possible outcomes, and this is the required condition, and the continuous minimum and continuous maximum. Minimum, continuous minimum, we say that this is continuous minimum and this is continuous maximum. When we put continuous minimum and continuous maximum in equation number 1 as 1 as a continuous minimum, and x as it is, and 5 as a continuous maximum. We also discussed that we have one number c should be 0. Then what is c? We have given in the question number 10 as sir, f of x equal to minus 2x plus c. Sir, we have changed c to c as f of c equal to minus 2c plus 6. Then but there is x, okay, sorry. Then we have I think c equal to 3, right? Sir, we have a short graph right there. Go there. Set tangent with slope having two possible outcomes, a equal to 1, b equal to 5, and c, which we have said that it must be 0, but there his value is c equal to 3. We have to draw it, right? Sir, ignore my graph because I have no camera stand or something else. Otherwise, wait a minute. So this is tangent with slope, right? Two possible outcomes, right? Third given outcome, there are 2 points as well. There is a function f of x which is previous page, right? X plus 6x plus 6, and when we put it on the given condition, then it should be minimum continuous as well as maximum continuous, right? This is my Rolle's theorem, and I have tried my best to give a very short explanation about Rolle's theorem due to shortage of time and not much accessories of camera stand or. So I hope you like it. Thank you, sir.